This is Gail Kovac for Gresham Barlow School District, and this is a summer school, high school credit recovery, geometry, and learning target number 10. I can use formulas to find the volume of various figures. So we are now looking for three-dimensional space that a three-dimensional object will take up. So in this first example here on the left, we've got a prism. A prism has a particular shape that is stretched from the top to the bottom, which matches. And on the right, we have a cone. And a cone or a pyramid has one shape at the bottom, but instead of extending up to a congruent shape on the other side, it extends up to a point. So we have different methods that we're going to use for either of these. So what we want to do essentially is find the area of the base shape and then multiply it by our third dimension going upwards, either fully if it is a prism or partially if it is a cone or a pyramid. So let's start with the 1, 2, 3, 4, 5, 6, the hexagonal prism, which is here on the left. I've got a hexagon on the bottom and on the top. I want to first find the area of the hexagon and then bring that up into the third dimension through multiplication. So let's see here at this six-sided figure hexagon. It is essentially made up. It is a regular hexagon. You can tell because the tick marks for the side lengths are all the same, as well as the angle measures, so that makes things nice and easy. It is essentially made up, if you cut it up like a pizza, it is made up of lots of congruent triangles. Now I'm going to find the area of one of these triangles and then multiply by 6 because I have 6 of them. So if you remember, the area of a triangle is 1/2 of the base times the height. So I need to find the base and the height, multiply those to get the area, take half of it, and then I'll multiply that by 6. So my base here is actually the same as this base here. Since it's tick marker congruent, it is 4. So the base is 4, and the height of the triangle is actually the apothem. That's the distance from the center of the hexagon to the flat side. So to find the triangle, I'm going to take 1/2 of 4 times 3.5. And let's see what that is. All right, so 4 times 3.5, that's 14. And I'm going to divide that by 2, and I'm going to get 7. So the area of one of these triangles is 7 feet squared. But I've got 1, 2, 3, 4, 5. I've got 6 of these 7. So to find the area of the hexagon, let's see if I can do this here. 4, 5, 6 is going to be the area of the triangle times 6. And we found the area of the triangle already. That's 7. So 7 times 6. All right, so the area of the base, so the base shape is the hexagon, is going to be 42. So that's 42 feet squared. That gets you the entire base. Now that's the area of the base, but we want to bring this up into the third dimension. So now we are going to be multiplying this by the height of the prism, and the height of the prism is 3. So to find the height of the prism, I'm just going to kind of make this look a little cruddy, but I think you get it, right? 1, 2, 3, 4, 5, 6, right? That is going to be the area of the 2, 3, 4, 5, 6 of the base, and we're going to multiply that by the height, which is 3. So the area we found of the hexagonal base is 42, and we're going to multiply that by the height of 3. That's going to get us our total volume here. So 42 times 3 is 126. So that is 126. Now this is feet, but this is now cubic feet. This is feet cubed or to the power of 3 because now we are in 3 dimensions, length, width, and height to find total volume. So identify the shape of the base first for a prism. It should have the same shape on the top and the bottom, and those side lengths should just go straight up. and then you will multiply the area of the base times the height of the shape to get the full volume. Now in our second example, we don't have a prism, so I have a circular base, but I don't have a circular shape on top. That would make a cylinder instead, which is a prism. I have a pointed shape on the end here, so that is a cone instead. So I'm going to first treat this like it's a cylinder, find the area of the base, multiply that by that height to bring that into the third dimension. But then I'm going to do something special since it just comes to a point rather than to another circle. So let's find the area of this base to start. So the area of a circle is pi r squared. Oops, I'm trying to do a pi. That does not look like pi. There you go. Pi r squared. Now the radius is not 18. That's the diameter. That's the full distance across the circle from the middle. So right here, this is your radius. Radius is the distance from the center of the circle to any point on the outside. It is half the diameter. So if the diameter is 18, then that radius is going to be 9. So the area of the circle is going to be pi, which is 3.14. Started writing 3 above, that's what that was. And then I'm going to multiply that by 9 squared. So 3.14 times 81 will approximate the area of the circle at the bottom times 81. All right, so let's get my calculator to help me out there. And I get an area of the circle of 254.34. 254.34. That is the area of the circular base. Now, if I wanted to bring this up into the third dimension, I would multiply by the height of the 3D shape of the cone, in which case that's going to be 18. So the area of the cone, if this were a cylinder, if this were a full cylinder with a circle on top and circle on bottom, then you would just multiply the area of the circle times your height. Okay, so let's pretend it's a cylinder to start, and then we're going to change something. So the area of the circle we had was 254.32. Oh, 34, sorry, not 32, 34. Okay, and then I'm going to multiply that by my height of 18. That's going to get me the area of a cylinder if this were a cylinder. It's going to be a big, big number. 4, 5, 7, 8, and 12 100ths. Okay, but that's for a full cylinder. However, this does go up to a point. So a point instead of another circle. Now, what's this called? A cone will fit a number of times into a cylinder. In fact, this cone will fit exactly 3 times into the volume of its mother cylinder. So if I know the cylinder's volume, all I need to do is find 1/3 of that to get the cone. So the cone is going to be 1/3 the volume of a cylinder. 3 of them would fit inside. They'd have to squish and that kind of thing, but 3 of them would fit inside. So I'm going to find 1/3 of my cylinder volume up there. 4, 5, 7, 8.12. That will get you the area of just the cone. So I'm going to take that and divide by 3 to find 1/3 of it. It is 1,526 and 0.04 approximately. And don't forget to use your units. This is in miles, so this is going to be miles cubed because we just found a volume which lives in 3 dimensions, so third dimension there. So just remember, if it is a prism, it is the area of the base, whatever shape that is, multiplied by your height. If it happens to be a cone or a pyramid, you still do the same thing. You'll multiply the area of the base times the height, but then you're just going to divide that number by 3 at the end to find 1/3 of it, because 3 of them will fit into the full prism.